this video, we'll go over Part C of the Google Sheet activity, distribution and outliers, and we're going to be focusing on normal distributions. As we said above in Part B, there are 4 different ways you can determine whether a distribution is normal. The first criteria is whether the mean, median, and mode are either equal or very close to being equal. The second is if the skewness is 0 or close to being 0. The third is if the graph is a bell shape. And all of those individually aren't always enough to determine for sure whether it is normally distributed or not. There is a fourth piece of evidence, which we're going to go over in this part of the activity, and it's a bit of work, but it gives you a much better idea of whether it is normally the data is normally distributed or not. So we're going to be filtering our data, and when you do that, please remember, when you're filtering data, you have to have your data in one sheet and your calculations in another sheet. So we will have to house the data in the normal distribution sheet, which is here, and we're going to do the calculations in the other sheet, which is called normal distribution calculations. Also remember, you need to, after you have filtered the data, you need to copy and paste the data into another sheet before you do any calculations. So, in this activity, we are looking at the heights of 1,000 high school students from the Census at School survey. In order to complete this activity, for other examples, make sure you know how much data you start with, because it won't always be 1,000. Now, in the normal distribution sheet, which we're here, highlight cells A2 to A1001, and we're going to name that range because we're going to be doing a lot of calculating there. So highlight it, make sure it goes all the way down to the bottom, and we're going to name it heights. Now we already have height, but this time we're going to do heights. Now we're going to create a histogram with a bucket of 5. So insert, chart. It's automatically going to come up thinking we're going to make a histogram, and we're going to customize it, and we're going to make the bucket width 5. And we'll format this a bit more. So under chart and axis titles, the chart title, we don't want to say histogram of height, we'll say heights of high school students. And the horizontal axis, we're going to have to add in the units. And the vertical, we're going to put frequency. And there is our histogram. So as you can see, the graph is bell-shaped and almost symmetrical. So remember, this is real life data. This was not arbitrary data that we made up like in Part B. This is real data, so it is unlikely that it's going to be perfectly symmetrical and perfectly bell-shaped. You have to think, is it close enough? So it's almost symmetrical, which indicates that the data closely resembles a normal distribution. Now what you're going to do is go to the normal distribution calculation sheet, and we're going to calculate the mean, median, and standard deviation. So over here, we're going to calculate the average of the heights and the median of the heights and the standard deviation of the heights. And here is your second piece of evidence, is that the mean and the median are almost the same. So your first piece of evidence is that the graph is almost bell-shaped. Here you can see the mode is between 165 and 170, so if you average that, it would be about 167.5. And so the mean, the median, and the mode are all similar to each other. So there's your second piece of evidence. Now what we're going to do is determine how much data is within one standard deviation of the mean. So your mean is 166.96 approximately, and we're going to calculate the mean minus the standard deviation. So we're going to take the value of the mean and subtract the value of the standard deviation, and that gives you 158.4 approximately. And then we're going to calculate what we call the upper fence, and we're going to take the mean, and we're going to add the standard deviation, and you get about 175.4 or 0.5. And what we're going to do is find out how much of this original data is between 158.4 approximately and 175.5. We're going to find out what percentage of those 1,000 people are within that range here. So in order to do that, you're going to go back to the normal distribution sheet and you're going to filter the data to be between the values that we calculated here. So between 158.366, etc., and 175.544. So back into normal distribution. So we're going to take this data and we're going to create a filter. And we're going to filter by condition. It's going to be between. And we're trying to find out how much data is between 158.37 and 175.54. Now to see how much data we have within that range, you're going to highlight column A, and in the bottom right corner you're going to see that it calculates the sum of all those values. We don't care about that. We're not interested in the sum. What we're interested in is how much of the data is in that range. So how many numbers, how many pieces of data were between these two numbers. So if you click on this and change it to count numbers, you don't want to say count because count includes the title of height. There are 673 cells, but there's only 672 numbers. So that means out of the original 1,000 students, 672 students have a height between 168.37 and 175.54. So that means there are 672 pieces of data within one standard deviation of the mean. So now we're going to go back to the calculations, and over here, the percent of data that is within one standard deviation of the mean. So that statement, when it says the percent of data within one standard deviation of the mean, that means what percentage of the data is within these two numbers. And these two numbers were found by taking the mean and subtracting the standard deviation, and taking the mean and adding the standard deviation. So we found out that there was 672 out of 1,000 pieces of data, and then multiply by 100 to change it into a percent. So there is 67.2% of the data is within one standard deviation of the mean. Now remember, that number won't always be 1,000. It's only 1,000 in this example because we started with 1,000 pieces of data. You may have another example later on where there is not 1,000 pieces of data, so this number would be however much data you have. So 67.2% of the data is within one standard deviation of the mean. In a normal distribution, there should be about 68% of the data within one standard deviation of the mean. Again, this is real data, not perfect data, so chances are you're not going to get exactly 68%, but we are close to it. So that's pretty good. Now what we're going to do is find out how much data is within two standard deviations of the mean. So the lower fence, we're going to take the mean and subtract 2 times the standard deviation, and we get about 149.8. And the other direction, we're going to take the mean and add 2 times the standard deviation. So that's what we did here. In cell C5, type in this formula, the mean minus 2 times the standard deviation, and C5, it's the mean plus 2 times the standard deviation. This gives the range of values that are within 2 standard deviations of the mean. So the range that is within 2 standard deviations of the mean is between approximately 149.8 and 184.1. So now we're going to find out what percent of the data lies within this range. So back to the normal distribution. We're going to change our filter, and now we want to know what percent is between 149.77 and 184.13. And again, if you highlight A, there are 952 numbers. So 952 students had a height between 149.77 and 184.13. So in our calculations, it was 952 students out of 1,000 students multiplied by 100 to change it to a percent. So there is 95.2% of students have a height within 2 standard deviations of the mean. In a perfect normal distribution, the number would be 95.5. So 95.2 is pretty good. Lastly, we're going to find out how much data is within 3 standard deviations of the mean. So we're going to repeat the process to determine what percent of the data is within 3 standard deviations. So the lower fence would be the mean minus 3 times the standard deviation. And the upper fence would be equal to the mean plus 3 times the standard deviation. So within 3 standard deviations, the range is approximately 141.2 to 192.7. So back over here, we're going to change our filter to be approximately 141.19 to 192.72. And when you highlight A, it gives us about 997 students. So 997 students have a height between approximately 141.2 and 192.7. So the percentage is, there was 997 students divided by the original 1,000 students multiplied by 100 to change it to a percent. So 99.7% of the data, or of the students, have a height within 3 standard deviations of the mean. In a perfect normal distribution, the percent of data within 3 standard deviations would be 99.7, so we're bang on. So this is altogether your last piece of evidence that there is whether your data is normally distributed or not. So if these percentages are approximately in the ratio of 68 to 95.5 to 99.7, that's your last piece of evidence that you have a normal distribution. So one thing I should add here also is the skewness is equal to 0. So those are your 4 pieces of evidence to determine whether a set of data is normally distributed or not. So the first thing is to make the graph and see if the histogram is bell-shaped or close to it. The second thing is to calculate the mean, the median, and the mode. So the mean and the median, and looking at the graph, the mode, are they approximately equal to each other? The third thing, you can calculate the skewness. We didn't do that. But over here, if we remove the filter, we could calculate the skewness. Oops. Heights. So it is approximately 0. It's a little bit left skewed, but it's approximately 0. So that's your other piece of evidence. And then lastly, our 3 percentages. Within 1 standard deviation was 67%. Within 2 standard deviations was about 95%. And within 3 standard deviations was 99.7%. Those are very close to the 68, 95.5, and 99.7 of a perfect normal distribution. So we could be fairly confident that this data, the heights of students, is normally distributed. So there's one more thing you need to take into consideration when looking at the graph. The bucket size makes a big difference, as well as even just the beginning value and the end value. So go back to the skewness tab and let's take a look at this normal distribution here. Make this a bit bigger to see. And I'm going to show you what happens when you change the bucket width. So when we have a bucket width of 1, we have a very bell-shaped and a very lovely normal looking graph. Now, let's take this chart and let's change the bucket width to 2. So if you change the bucket width to 2, you still have 1, 2, 3, 4, 5, 6. You still have between 5 and 10 bars, which isn't wrong, but it doesn't look as normal as it did when the bucket width was 1. So you have to be careful when you make these that you might want to play around with the bucket size to see if you can make it look a little more symmetrical. Now change the bucket sizes to each of the following and see how it changes the shape of the histogram. If we make the bucket size 1.5, we've got something that looks bimodal. Not very normal at all. If you change it to 0.75, you got something that looks like, this is often called a comb, like C-O-M-B, almost like if you're brushing your hair with a comb, because you kind of have gaps in between. So this is often called a comb distribution. If you change it to something like 1.3, you get something like this. Kind of looks like it's giving you the middle finger, but that doesn't look very normal at all. So the bucket size makes a huge difference when you're trying to decide whether your graph looks normal or not. So you might want to play around with a couple of different bucket sizes. As long as you're within that 5 to 10 range, then you're good. And that concludes this activity.